Welcome to Bite Size Tutorials, where we break down complex topics into quick, easy to digest lessons.
Imagine your database starts small, it fits neatly on one server and everything works great. Queries are fast, writes are smooth, and life is good. But as your data grows, things start to slow down. The server struggles to keep up with the load. Queries take longer and the system feels like it's crawling. You realize it's time to scale. The first idea might be to make your server bigger, add more RAM, more storage, and a faster processor. That's called vertical scaling, and it works for a while, but eventually you hit a limit. Servers can only get so big, and upgrading them gets expensive fast. That's when you turn to horizontal scaling, where you spread the data across multiple servers instead of piling it all onto one. This is where sharding comes in. Sharding splits your database into smaller chunks called shards. Each shard is like its own little database holding only part of the data. Together, these shards form the full system. Think of it like a massive library. Instead of putting all the books in one room, you split them across multiple rooms based on categories. Fiction in one room, science in another, and history somewhere else. Now, when someone needs a specific book, they go directly to the right room, saving time and reducing the load on any one librarian. In databases, you decide how to split the data using a shard key. This is a specific key, like a user ID or a geographic region that determines which shard holds the data. For example, let's say you're building a social media app. You might shard the user data based on user IDs. User with IDs from 1 to 1 million go to shard 1. The next million go to shard 2 and so on. When someone logs in, the system looks at their user IDs, knows which shard to check and fetches the data quickly. Another way to shard is by geography. If you run an e-commerce app, users in the United States can be stored in one shard, Europe in another, and Asia in the third one. This approach works well when your users are naturally distributed across regions. There's also range based sharding, where data is split into ranges. For example, orders from January to March go on one shard, April to June go on another, and so on and so forth. This works well for systems where the data has a natural range like dates, but range based sharding can run into a problem called hotspotting. Hotspotting happens when one shard gets overloaded with more data or traffic than the others. Let's go back to the range based system where the orders from January to March are stored on shard 1. Now imagine it's February and everyone is querying data from the current month. Shard 1 starts getting hammered with requests while the other shards sit idle. This overloaded shard becomes a bottleneck, slowing the whole system down. That's hotspotting. Hotspotting can also happen if your shard key isn't well designed. Let's say you use shard based on user IDs, but the IDs are sequential. All users will end up on the same shard, which means that shard gets overloaded while the others remain underutilized. This defeats the whole point of sharding because now you're just shifting the problem to one part of the system. To avoid hotspotting, you need to choose a shard key that distributes the data evenly across all the shards. A common solution is hash based sharding, where the shard keys pass through a hashing function. The hash then determines which shard the data belongs to. For example, instead of putting all new users on one shard, hashing spreads them randomly across all the shards. This balances the load and prevents any single shard from becoming a hotspot. But even with a good shard key, hotspots can still form over time as some shards grow faster than others. When that happens, you need to rebalance the shards. Rebalancing means splitting a large shard into smaller pieces or moving data to other shards to even things out. It's like rearranging a crowded library room that so that no one section gets overloaded. Sharding comes with other challenges too. One of the trickiest is cross shard queries. When you need data that's spread across multiple shards, the system has to query each shard, combine the results, and return the final answer. This is slower than querying a single database and can become a bottleneck if done too frequently. For example, calculating the total number of users across all shards requires hitting every shard, collecting the counts, and summarizing them up. Despite these challenges, sharding is one of the most powerful ways to scale a database. By splitting your data across multiple servers, you can handle more traffic, store more data, and keep your system running smoothly. The key is to plan carefully, choosing a shard key that balances the load, watch out for hotspots, and design your systems to handle rebalancing and cross shard queries when needed. In the end, sharding is like breaking a big job into smaller tasks and assigning each one to a different worker. When done right, it can turn a slow, overloaded database into a fast and scalable system that grows with your needs. Just remember, the key to successful sharding is even distribution. If you can keep the load balanced and prevent hotspots, you will have a system that performs like a well oiled machine, no matter how big your data gets.